Hello, today we are going to learn data link layer in networking. In Module 3 we have these topics: MAC addresses and Ethernet, LAN technologies, for example VLAN, STP, LACP, error detection and correction. MAC addresses and Ethernet. MAC media access control addresses are unique identifiers assigned to network interface controllers, NICs, for communication on a network. MAC addresses are a crucial component of Ethernet, the most widely used wired networking technology. Ethernet. Ethernet is a protocol that specifies how data is transmitted over a physical network. In Ethernet, data is transmitted in the form of frames, which consist of a header and a payload. The header contains information such as the source and destination MAC addresses, while the payload contains the actual data being transmitted. When a device wants to transmit data over Ethernet, it first checks the destination MAC address to determine whether the destination is on the same network or a different network. If the destination is on the same network, the device sends the data directly to the destination device using its MAC address. If the destination is on a different network, the device sends the data to a router, which forwards the data to the destination network. To ensure that each device on the network has a unique MAC address, the IEEE Institute of Electrical and Electronics Engineers assigns a unique 48-bit MAC address to each network interface controller. The first 24 bits of the MAC address are assigned to the manufacturer of the NIC, while the remaining 24 bits are assigned by the manufacturer. Ethernet supports different speeds ranging from 10 Mbps megabits per second to 100 gigabytes per second gigabits per second, and is widely used in LANs, local area networks, and WANs, wide area networks, for connecting computers, servers, printers, and other network-enabled devices. LAN technologies, for example VLAN, STP, LACP, LAN, local area network technologies, refer to the different protocols and technologies used to establish and manage local networks within a small geographic area, such as a building or campus. Some of the common LAN technologies are VLAN, virtual local area network. VLAN is a technique used to create logical groups of devices that are not necessarily located on the same physical network segment. VLANs enable network administrators to partition a single physical network into multiple logical networks for security, traffic management, and flexibility purposes. STP, spanning tree protocol. STP is a protocol used to prevent network loops in a LAN. It identifies and disables redundant links in the network, allowing traffic to flow only through active links. LACP, link aggregation control protocol. LACP is a protocol used to aggregate multiple physical links between switches or routers to form a single logical link. This enables higher bandwidth and redundancy, as well as load balancing and fault tolerance. Ethernet. Ethernet is a popular LAN technology that defines the physical and data link layers of the OSI model. It is used to connect computers, servers, and other devices in a LAN using copper or fiber optic cables. Wi-Fi. Wi-Fi is a LAN technology that enables wireless communication between devices within a limited range. Wi-Fi is commonly used in homes, offices, and public places, such as airports and coffee shops, for connecting laptops, smartphones, and other mobile devices to the internet or to other devices on the same network. MPLS, multi-protocol label switching. MPLS is a LAN technology that enables efficient and reliable data transmission over a wide area network. It uses labels to direct traffic along PRI-determined paths, reducing network congestion and improving network performance. Overall, LAN technologies are essential for establishing and managing reliable and efficient local networks, and they play a crucial role in the functioning of modern business and communication networks. Error detection and correction. Error detection and correction are techniques used to ensure the integrity of data being transmitted over a network or stored in a storage medium. Error detection involves adding extra information to the data being transmitted or stored, which allows the receiver to detect if any errors have occurred during the transmission or storage. This extra information can be in the form of parity bits, checksums, or cyclic redundancy checks (CRC). Parity bits are simple forms of error detection that involve adding an extra bit to each character or byte being transmitted. If an error occurs during transmission, the receiver can compare the received parity bit to the expected value. Checksums are more complex forms of error detection that involve adding up the values of all the characters or bytes being transmitted and then creating a checksum value that is transmitted along with the data. The receiver can then perform the same calculation and compare the calculated checksum to the received checksum to detect errors. CRC is another widely used form of error detection that involves generating a remainder value by dividing the data being transmitted by a PI-defined polynomial. The remainder value is then transmitted along with the data. The receiver can perform the same calculation and compare the calculated remainder value to the received remainder value to detect errors. Error correction, on the other hand, involves adding even more information to the data being transmitted or stored, which allows the receiver to not only detect errors but also correct them. Techniques for error correction include forward error correction (FEC) and automatic repeat request (ARQ). FEC involves adding redundant data to the transmitted data, which allows the receiver to correct errors without needing to request retransmission of the data. ARQ, on the other hand, involves the receiver requesting the transmitter to resend data that has been detected to have errors. ARQ can be either stop and wait or continuous, depending on whether the receiver waits for the entire data block to be received before requesting retransmission, or request retransmission immediately upon detecting an error. Overall, error detection and correction techniques are important for ensuring reliable and error-free data transmission over a network or storage medium. Thank you for watching us. Stay tuned for our next video.